exists between the planet Earth and the planet Jupiter. Obviously, this is not drawn to scale because Jupiter is way bigger than the Earth, but that's okay. So gravity is pulling the Earth towards Jupiter, and gravity from the Earth is pulling Jupiter towards the Earth, and the distance between them is given here in green by r. The masses of the planets were given in the problem, as well as the distance between them, and we're just trying to find that force of gravity. So we're going to use the equation for Newton's law of universal gravitation, which is the force of gravity equals big G, mass of the Earth, times the mass of Jupiter, divided by the distance between the two of them, squared. Now we just have to plug in our numbers, and we should be able to solve. I probably have to write pretty small because these are pretty long and large numbers. G, we've learned, is a constant, so it's always 6.67 times 10 to the negative 11. That's Newton meters squared per kilogram squared. Mass of the Earth is 5.97 times 10 to the 24th kilograms. And the mass of Jupiter is 1.9 times 10 to the 27th kilograms. And we are going to divide that all by the distance between them, which is 7.78 times 10 to the 11th meters. And we square that. When you plug it in, you should get an answer of about 1.25 times 10, it's a terrible 10, times 10 to the 18th newtons. Now, if you do not get the 1.25 times 10 to the 18th newtons, check your calculator and make sure that when you put this big equation into your calculator, you put a parentheses around your denominator and that you squared it. Otherwise, you are going to do all this top part, and if you just hit divide and forget the parentheses, you divide this whole top part by 7.78, but then your calculator thinks you want to move the 10 to the 11th back up to the top because you didn't put the parentheses. So make sure you have those, and you should get the right answer.